Hey guys, hope everybody's having a great week learning about quadratics. So we've talked about quadratics in standard form, and if you remember that was ax squared plus bx plus c. We talked about yesterday doing quadratics in vertex form, and to do that it was, let me find a place to write this, vertex was y equals x minus or plus h plus or minus k. And again, those signs could change, but that's what it looked like, and it gave us like h and k were your vertex. So it was h comma k. And then today we're going to be doing factored form. So remember when we factored trinomials and we did the x puzzles? That's what this is going to look like. So it's going to look like y equals x minus p times x minus q. Why p and q? I have no idea. But that's what it's going to look like. So it's going to look like you just factored a trinomial, and from there we'll be able to tell some different things. It's going to be able to tell you one more thing than what we've been able to tell with standard and vertex form. We'll be able to find your solutions or your x-intercepts. So quick review. If a is greater than 0, aka the a is positive, your graph is going to be opening upward. Hopefully you've got this memorized by now. We've done it like every day for the past 4 days. And has a minimum because the vertex is at the lowest point on the graph. If a is less than 0, aka it's negative, the graph is going to open down. That means that the graph has a maximum point because that vertex is at the highest point on the graph. Okay. Then I have this picture here. We know how to find the y-intercept, so that's just where our graph crosses our y-axis. So in this case, this would be our y-intercept. We have our x-intercepts. Again, this one has 2. You could have 1, 2, or none. This one has 2. X-intercepts. And remember, socks. Other words would be solutions, zeros, or x-intercepts. All of those things mean the same thing. So I've asked you, what's the solution to this quadratic equation? Again, I'm asking you, where is it crossing that x-axis there? Next, we have the vertex. So that's this little point right here. Again, it is opening upward. So this is going to be a vertex that is a minimum. It is the lowest point on our graph. Axis of symmetry is what cuts down the middle of the vertex, and it makes both sides of your parabola symmetrical. If I were to fold on that green line, the left side and the right side would meet up perfectly. Axis of symmetry. Okay. So there's our graph. This time, in factored form, guess what? We can find all of it. We can find every single thing, which is pretty cool. So how do we find the x-intercept? So that's a little bit different than what we've been doing. These are from your factors. So remember, it was in that x minus p times x minus q. Well, your x-intercept equals, x-intercept equals your p and your q. One important thing to remember, though, is switch your signs. So like we did with vertex form, you're going to have to switch your signs for both p and q. So if it's negative p, it's really going to be a positive p. If it's positive q, it's really a negative q. So remember to switch those signs when you take it out of there. How do we find zeros? That's the same as x-intercepts. Okay, so remember these two things are exactly the same, x-intercepts and zeros. And then how do we find standard form? So standard form is just going to be distributing. And what I mean by distributing, it's in those factored forms. So you can either do FOIL or box method. Either one will work. So y-intercept, once you have this in standard form, you just look at whatever your C value is, and it's 0, comma, whatever C is. So remember how we did that? AX squared plus BX plus C. You're just looking at that C value. Vertex. Again, we're going to use that formula. X is going to be equal to that negative B over 2A. And then you're going to plug it back in to figure out what your Y value is. So that's that. Axis of symmetry, you're just using X equals negative B over 2A. So this part right there of that. How do we find if it's a max or a min and the range? These two things kind of have to do hand in hand. If A is greater than 0, we've got a minimum. And you're using that F of negative B over 2A. And that means that your range is going to be Y is greater than whatever this number is we got from our Y value. If A is less than 0, you've got a max at F of negative B over 2A. Again, it looks kind of funky right now because I'm using all these formulas, but it's not bad when I've got the numbers in here when we start doing examples. And that means that your Y is going to be less than or equal to whatever that Y value is. Again, this is just saying I'm plugging it back in to get the Y value. Domain is always negative infinity, positive infinity, or your fancy R, all real numbers. And that is how you find everything. Neato. Okay, let's try it. So here's our factored form here. We've got Y equals X plus 3, X minus 4. Your X-intercepts, remember, are your P and your Q. So here's P, here's Q, but remember we have to switch signs. So it was a positive 3, so now it's a negative 3. So the first one is negative 3, 0. And then your next one is, it was a negative 1, so now it's positive 1, comma 0. So those are your two X-intercepts. Remember, X-intercepts and zeros are the same thing. So I'm going to literally write the same thing here. Same. So there's two free answers. Standard form. So now I've got to FOIL or box method this thing out. I'm going to use box method because I think most of us like that. So X plus 3, X minus 1. So then when I do this, I've got X squared, 3X, negative 3. Combine my like terms, and I'm left with X squared. 3X minus X is plus 2X minus 3. So that it would be our standard form, X squared plus 2X minus 3. From there, I can look at the C, and that will give me over 0, over 0, and then down negative 3 is my Y-intercept. Okay? Now to get axis of symmetry, I have to use that formula again. So I'm using the X equals negative B over 2A. X equals negative B over 2A. And I'm using that standard form. So in this case, A is 1. There's nothing there, right? And then my B is 2. So I've got negative 2 over 2 times 1, which is just equal to negative 1. So my axis of symmetry is at X equals negative 1. To get the vertex, it's negative 1. Again, I'm using this. Then I plug it back in to the X squared plus 2X minus 3, except I'm plugging in negative 1. So I really have negative 1 squared plus 2 times negative 1 minus 3. And if you want to save yourself a little bit of work, you can plug it into Desmos. So I've got negative 1 squared plus 2 times negative 1 minus 3, and I get negative 4. So that would be my y value, which is going to go right here. So there's all of that. Max or min, again, this is positive. Okay, if I look here, this is opening upward. So that means that this is going to be a minimum at y equals that -4. The range, since it's a minimum, is going to be greater than or equal to that -4. And then domain, again, is always, always, always the all real numbers, or negative infinity to positive infinity. And there it is. So a little bit of work, but not too difficult, I don't think. Let's try another one. Get kind of used to this. Okay, number 2. First off is x-intercepts. So I'm looking at the P and the Q. Again, I have to switch signs. So it's going to be over 6, 0 and 4, 0. So remember, these were negative and negative, but when I take them out, they're going to be positive. So that's why I got to switch the signs. Again, x-intercepts, zeros, literally asking the same thing, so I get to write the same exact thing. There's a little free answer. Standard form, I have to factor this out, or box method, or whatever y'all like to do. So I'm going to do box, x -6, x -4. So when I do this, I'm left with x squared minus 6x, -4x, and -4 times -6 will be positive 24. Combine my like terms, so I'm left with x squared, -6 minus 4, same signs we add, so I really have -10x plus 24. So there's my standard form. Squared minus 10x plus 24. My y-intercept, I'm looking at that last term, that c term, which is 24. So I'm going over 0, up 24 for my y-intercept. Axis of symmetry, I've got to use the -b over 2a formula. So whoop, x equals -b over 2a. In our case, our a is that imaginary 1 there. And our b is -10. So then when I plug this in, I really have, if I plug a -10 in, negative times a negative gives me a positive over 2 times 1. So really it's 10 divided by 2, which is 5. So axis of symmetry is x equals 5. Then when I go to find the vertex, I have to plug everything back in. So I'm using the x squared minus 10x plus 24. But now I'm plugging in 5 everywhere I see an x. And again, I'm going to cheat. I'm going to use Desmos. I'm going to plug all of that in. So I'm left with 5 squared minus 10 times 5 plus 24. And I end up with -1. So for my vertex, I've got 5. Again, I'm getting that from here, comma -1. I'm getting that from here. Max or min? Well, if I look back at the original, it is positive, so I know it's facing upward. So I've got a minimum. It's the lowest point at y equals -1. Since it's a minimum, I have to be, everything has to be greater than or equal to that -1. And domain is always, always, always all real numbers. Oops, sorry. Let me zoom out for you. And there we have it. Okay, next one. X-intercepts. Again, I'm looking at the P and the Q. So they're both positive, so really they're going to be negative. So +4 is going to turn to -4, 0. And this one is going to turn to a -2, 0. Again, these two things, solution 0, x-intercepts, are all asking the same thing. So I get to write the same thing here. That part's easy, right? Gives it to us. Standard form, I have to do box method or FOIL or something. So I've got x plus 4, x plus 2. So I really end up with x squared, 4x, 2x, and 8. When I combine my like terms, I've got x squared plus 6x plus 8 as my standard form. Oops. To get my y-intercept, I'm looking at that c term, so it's going to be over 0 up 8 to get my y-intercept. Axis of symmetry, I've got to use the formula x equals negative b over 2a, and I look at my standard form to get those numbers. Again, x is just 1, so there's an imaginary 1 there for a, and then b is positive 6 this time. So when I plug all that in, I've got 6 over 2 times 1, so I really end up with 6 divided by 2, which is 3. Right? Oh, and I forgot my negative, sorry. So it is negative 3. So x equals negative 3. When I try to find my vertex, I have half of it already. The x part of the vertex is negative 3. I'm getting that from my axis of symmetry. To get the y part, I've got to plug in to x squared plus 6x plus 8. I'm plugging in negative 3 everywhere I see an x. And again, I'm going to cheat, plug it in Desmos. And this time I've got negative 3 plus 6 times negative 3 plus 8. And I get negative 1. So that is where my y value comes in. I look up here. This is a positive. Okay, there's a positive in front of here. So I know that this parabola is going to be facing upwards. So I know that I have a minimum at y equals negative 1. The range, since it's a minimum, is going to be y is greater than or equal to that negative 1 value. And domain for every parabola is always all real numbers. Or again, you can always write negative infinity to positive infinity. So just doing box method, axis symmetry, all of that stuff from the previous lessons. Okay, number last. It looks a little bit different. So normally I had like the x, it looks like, let's write it out, x minus p times x minus q, right? Well, I have the x minus q part, but the other one's missing one. So if I were to write this out, it would really be x plus or minus 0, right? Doesn't really matter. And then x minus 5. So then if I were looking for my p and my q, the intercepts are going to be 0, 0, and 0. It was a negative 5, so now it's going to be a positive 5. And let me use red. Let me stick with my colors. So p, q, 0, 0, and 5, 0. Again, 0 solution, x-intercept all mean the same thing, so I'm going to write the same thing here. Standard form means I'm going to be doing distributing. In this case, distributing is not going to be too terribly bad because it's just x times x minus 5. So I can just distribute this x to everything inside. So I'm left with x times x is x squared, and x times negative 5 is negative 5x. So that would be our standard form. Y equals x squared minus 5x. If I'm looking for that y-intercept, so I'm looking for that c value, notice there's no c. So it's really c is plus 0. So the y-intercept is at 0, 0. Remember, don't use this number just because it's the last term. Your c value is always what's last. So it's always what's not next to that x value. Okay, axis of symmetry. Again, I've got to use the negative b over 2a formula. So when I do that, I've got x equals negative b over 2a. In this case, my A is 1, so imaginary 1 there, and my B is -5. So when I plug all that in, I've got x equals -5 is really a +5 over 2 times 1. So it's really just 5 over 2. So x equals 5 over 2. So if I do my vertex, I have the first point, 5 over 2. To get y, I plug it back in here. So x squared minus 5x. So it's 5 over 2 squared minus 5 times 5 over 2. So let's cheat. Let's go plug it into Desmos. And I've got 5 divided by 2. Square that whole thing. Minus 5 times 5 divided by 2. Oops, that's not divided by 2. And I get -6.25, or if you want it as a fraction, -25 over 4. So that's there, because this equals -25 over 4. Max or min. So if we look, it is positive right here, so I know that it is facing upward. So I know that this is a minimum point. My vertex is the lowest at y equals -25 over 4. The range, since it is a min, everything has to be greater than or equal to -25 over 4. Domain is always, always, always all real numbers. Okay, again, just like the other ones, if you wanted to, you could plug in this into Desmos just the way you see it. It will work. And you can plug in y equals x plus 3 times x minus 1. And look, I can get the vertex, which is -1, -4. Which if we look, we said the vertex was -1, -4, right? That gives us our axis of symmetry. If we want to find the zeros and the x-intercept and all that, here's our zeros, -3, 0, and 1, 0, which is what we said, right? -3, 0, and 1, 0, x-intercept and zeros. We can also look at our y-intercept, so where it crosses the y-axis. So right here is where it crosses the y-axis at 0, -3, which again, that's what we said right there. And you can get everything else from there as well. So if you do want to graph it or check yourself using Desmos, I am totally fine with that, using Desmos to graph. So now you know how to find all the attributes from graphs, from standard form, from quadratic, factored form, and vertex form. Bye, y'all. I hope you'll have a great rest of your day.